in action potential in series of physiology meet easy. Now, in this representation, I will take action potential in nerve. Nerve resting membrane potential is nearly minus 70 millivolt, and this will be depicted in as so. This is the resting membrane potential 1. And the phase 2 is a threshold level. Up to this level is a graded potential or electrotonic potential. And from here to here, this point is the depolarization phase. So it's a rapid depolarization phase. At this point, spike or peak of the action potential obtained. From there, you will find fourth phase, that is repolarization phase. From the spike potential, it goes on and it is hyperpolarization. And again, you will find resting membrane potential. So you will find in detail that is a resting membrane potential, this one. And these are the initial potential developed or initial depolarization phase which failed to propagate action potential. And this is known as electrotonic or graded potential. After that, depolarization, full-fledged propagated depolarization phase developed, which towards the positive side. And once it comes to the negative side, it is repolarization. And after the resting state, it is hyperpolarization because membrane become more negative. And after this phase, it comes to normal resting state. So you will find in the resting stage, there is a potassium more permeable outside. That is for leaky channels. This is for leaky channels. And the sodium potassium voltage gated channels, they get opened over here, this part. Here voltage gated sodium channels open, responsible for depolarization, and inactivation of voltage gated sodium channels and activation of potassium channels is responsible for repolarization. So in this phase, potassium ions out and positive sodium ions, they come inside. After that, you will find potassium ions continue to exit. And in this phase, there is 2 ions of the potassium comes inside and 3 sodium ions, they goes out. So there are 5 phases. One is the resting membrane potential, then graded potential, and then depolarization, repolarization, hyperpolarization, again resting membrane. Now what is the explanation for the action potential? This voltage dependent sodium channels explains the initiation of the action potential because they remain closed, but after some potential it opens, and this is the responsibility for creating more positiveness inside the membrane. So increase in sodium permeability would produce a greater depolarization, and greater depolarization, greater number of the sodium channels opens. So the greater depolarization, greater number of sodium channels opens, and it become greater depolarized, membrane become more depolarized. This is known as positive feedback or regenerative cycle. So this is a very good example of positive feedback mechanism or regenerative cycle, that sodium entry of the one sodium ion, it will accelerate other entry of the other sodium. But what is the difference between the sodium and potassium voltage gated channels? The main difference is potassium channels are slow to open, and once it opens, it is difficult to close, you can say, or it will open for longer time. Second thing, sodium influx lead to positive feedback cycle rapidly. But you must remember, with a single action potential, with the amount of the sodium which comes inside and amount of the potassium that leaves the cell membrane are insignificant. As I told you in the previous lecture of resting membrane potential, that 1 by 10 lakhs and 1 by 50 lakhs is required of the potassium ions that is lost during one action potential. So once there is a series of the action potential, this is about the one single. But if there is a series of action potential, then sodium potassium pump is responsible to maintain the equilibrium potential. So the point should be noted that the voltage gated channels have an activation gate and open till the membrane potential reaches a specific voltage. So at the specific voltage means that minus 40 millivolt, there is opening of sodium channels which depolarizes the cell. So this is in the phase of depolarization that sodium ions, they come inside. So at the peak of the action potential, what will happen? Sodium channels inactivate and potassium channels activation occur. Now this is the gist of action potential. Now if you presume, mind it, it is your imagination, that inside the action potential area is the intracellular. It is rich in potassium, it is rich in proteins, anions, other anions. Here you will find it is extracellular fluid and it is rich in sodium and chloride, calcium. So we will take one by one. Resting membrane potential, phase 5. After the phase 5 comes again the 1, resting membrane potential. And this resting membrane potential is gradient is achieved, gradient of the difference of concentration of potassium and sodium ions is achieved by sodium potassium ATPase pump. So the pump is very important here, which what it do? It allow the 3 sodium ions outside and 2 potassium cations inside. Why? Because after the depolarization, more concentration of sodium. So this gradient has to be maintained there as a resting membrane potential. For that, sodium ions has to be moved out. Now this is done by sodium potassium ATPase pump. Now the second thing, the leaky channels are more permeable for potassium ions. The red indicate potassium and the green indicate sodium ions. So the potassium ions more permeable at the resting stage. Only few or less amount of sodium ions enter. But at this point, you will find more amount of sodium enter inside the cell. So it creates positivity. But it is responsible for electrotonic current or local current or graded potential, which is non-propagated. It occurs rapidly, but it attenuates rapidly also. So you will find it is non-propagated. But at the level of threshold, when it becomes more depolarized, more entry of the sodium ions. It is an example of positive feedback mechanism or recycling. So you will find more entry of the sodium ions and it becomes more positive. And it goes on till you will find inactivation of sodium ions that is in dotted line. So this inactivation of sodium ions channels is responsible for peak of the action potential, and there is opening of potassium ions. So the potassium channels, they get open and gradually they increases. And so what will happen? More concentration of potassium outside, and you will find this will continue even after the resting membrane potential, and you will find this even it remains open. So the potassium ion concentration become more here. Negativity creates much. So the phase 5 again attained after from hyperpolarization to the resting membrane potential. So you will find the gist of the action potential if you presume that this is the intracellular compartment and this is the extracellular compartment, that the sodium ion more concentrated in the extracellularly, and intracellularly the potassium ions are more concentrated. And picture will be the same in the resting membrane potential. Thanking you.